Okay, let's talk about the second station, which is the Whimhurst machine. So the first thing we need to do is talk about what's actually going on here. So I'm going to be using these rods, and they are separated by about an inch. And when I turn the rod, there's going to be electric charges that are pulled off and stored in the chambers here. Those electric charges are going to build a negative charge on one side, and they're going to induce a positive charge on the other. More on induction in the next station. So what happens is you get a charge imbalance. You get negative charges on one side, positive charges on the other, and eventually when the charge is large enough, it'll jump that gap. If you put them close together, it'll jump the gap easier. Further apart, it'll be much harder. So if I want to make this more interesting, what I'll do is I'll make the gap quite large between. In fact, so large that it's not going to be able to jump on its own. I could spin away for hours here and it's not going to build up enough charge to jump. So what I'm going to do is I'm going to put two objects in between to hopefully help the charge bridge the gap. The first thing I'm going to put is going to be this plastic bottle, and the second thing I'm going to use is a paper clip. So if I put the plastic bottle in between, okay, we'll build up a charge here, and you'll notice that once again it's not able to jump the gap. There's just too large of a difference between those. And the bottle doesn't seem to be allowing it to go through, at least not very easily, or at least not that we can see. If I do the exact same gap, or at least very close to it, but this time I put a paper clip in between, you'll notice a very different situation. Notice that now I can once again jump the gap here. And the reason is, the paper clip is what's called a conductor, and the water bottle is an insulator. Just like in the heat chapter, insulators will prevent the flow of whatever it is going through easily. So in insulators for the heat chapter, it was the flow of heat. It doesn't mean none gets through, it just means it travels through with a lot of difficulty, high resistance. The paper clip, it allows it to travel through much easier. Again, it doesn't mean that it's perfect, it just has a much lower resistance that allows it to jump through easier. So the paper clip is an insulator, or sorry, the paper clip is a conductor, the bottle is an insulator. You can do this with anything to figure out if it'll do it. Some objects will be somewhat in between insulators and conductors. For example, your skin is a pretty good insulator, but your body itself is a better conductor. So you can actually do the same thing with your finger in between there, but it'll hurt because, one, it's obviously a static shock, but two, it's going to build up more resistance than what the paper clip will, but less than the water bottle.